So welcome to the basics of weighing. So this is just for a simple weigher which a feeder feeds into it. So what we've got here on the graph is, on the left hand side here, a scale of 0 weight up to 150. In this case we've set this to our maximum wear capacity. And then time is over here. Then for our example, we've got here a target weight of 100 kgs. We've got a tolerance of 5 kgs, so that if the weight ends up with under 105, it's okay, and a lower tolerance of 4 kgs, so if the weight ends up with more than 96 kgs, then it's okay. And we've also got an in-flight value here, this blue line, and the green line I'll come on to in a moment. So what happens is, if a feeder starts, just say it's the first feeder, then it starts to feed and material goes into the weigher, and then when it gets to the in-flight, this means that the feeder is stopped. Well, it may take a little while for it to actually stop, and then there might be some material in the air, and then it may take a little bit of just, I don't know, flowing through the feeder or any sort of thing, and then it settles out, and just say it settles here, and after a stabilization time, that's the moment that the weight will be checked. Now you can see that it's slightly overfed, so it's slightly above the target weight, but it's within tolerance. You can see there are two tolerance values, so that would be acceptable. What happens is, though, just say it's 2 kilos over the target weight, so what we do is we halve that and add it to the in-flight. So the in-flight here, this blue line, it should have cut off for a more accurate weight a little bit earlier. So if the target weight is 100 and we finished at 102, so we halve that, that ends up with 1 kg, so we add 1 kg onto the in-flight. So this in-flight now will end up after this to be 7 kgs, so slightly lower. So it's within tolerance, so that's fine. Now if I just take this away and we feed it again, so what happens is we go right there, it stops the feeder, and if it just settles out here, now this is below the lower tolerance, so it's not within tolerance, so we can't accept it. Now if you've got some jogging enabled, and you can have a number of jogs enabled, what happens is it starts the feeder very quickly for a jog time, and just jogs it maybe for half a second or something, or maybe 1 second, maybe less. So it runs the feeder, and it just may just end up like that. So that's it jogging there for half a second, say. So it's settled out, we're still below the lower tolerance, and then it might just jog again, in which case we are now within tolerance, so this weight would be acceptable. So in this case we've jogged once there and once there. Now traditionally you'd have a number of jogs enabled. It's often maybe 5 or 6, maybe 9 or something, so that it doesn't keep jogging forever. But this would be an acceptable weight now after jogging twice. Now let's just talk about 2-speed feeding. So if I just get rid of that. So 2-speed feeding, this green line here is what we call the fast slow change. So 2 speeds can be set up permanently, so it's fast and slow, or it could be set up as an analog value like a percentage. But either way we treat it like 2 individual speeds. So what happens is when the feeder starts to go, it feeds quite quickly. When it gets to the fast slow change, it slows down, and then when it gets to the in-flight, the feeder stops as usual. It takes a bit of time to do all its stuff, settles out, and stabilizes, and it's within tolerance there. So this is the transition between fast and slow. Now obviously the fast slow change should always happen before the in-flight, because otherwise you might never change to slow speed. Now you can have variable speed feeders that can vary all the time, but actually we've proven that it's very little advantage in doing that. So we have a fixed speed to run fast, that might be 100%, and then we'll set a slow speed, maybe 20% or something. And what happens is it's really down to the judgment of the person doing the tuning or commissioning to decide what those speeds will be. Now let's talk about wear calibration. So on this wear here, we've shown this to be half a volt. Now what happens is, when you've got a weighment, and just say this wear maximum capacity is 150 kgs, sorry. So just say we're going to weigh 100 kgs. We might just go and do it, and we might just end up just over 150 kgs, of course, because it might just be slightly over, and we still need to be able to read that. So that's why we would always calibrate a wear effectively to be able to read slightly over the maximum wear capacity. So if the analog signal is a 0 to 10 volt signals, we'd always calibrate it so that the empty 0 kg is at half a volt and the maximum scale capacity is at 9.5 volts. So that means you can slightly read over, as we have here, and likewise when it empties out, the weight might end up to be slightly under 0 kg. Now we'd tear that out, but we must be able to read that value. Now the span calculations. So for a wear with 150 kgs capacity, you would take the 0 first. So the 0 might end up to be a value like 205, it might be a value like 2000 or something. And then you'd put the weights on the wear, in our case here 150 kgs, and then you'd read the ADC units again. Now ADC stands for analog to digital converter in the PLC normally, and you'd read that again. So just say a value is at 4000. It could be 4000, it could be 30,000, it could be anything like that. So the span value, this is a value here, the ADCs per kilo is set for the full value, this is the value here, minus the 0 value divided by 150, which in this case adds up to be 25.3 kg, and that is the value that is used in the constants. I hope you found this useful. Thank you very much.